I need to start the recording. I always forget to do that, and I really apologize when I do forget to do that. Um, any other questions? Otherwise, I'm just going to start rolling into it here. Okay, I guess we're going into it. So today, as I said, we're going to be taking a bit of a break from sort of the what we've been talking about for the past few days with fetch. We're going to be going back to something a little bit easier to wrap our heads around, something that's a bit more conceptual and less code heavy. And we're going to be talking about two things today. So these are both sort of like smaller topics that I sort of wanted to combine into one day so we can sort of cover them both. First of all, we're going to be talking about a bunch of different headers you can include in requests and you might get back in responses and talk about what they're used for. So thus far, the headers we've talked about, we've sort of been pretty abstract about it. It's been like you can include some headers and get back some headers, but we haven't actually talked about what headers tend to be included in requests and what they mean. So we're going to go through a bit of that today. And then second, we're going to talk about this thing called CORS. And it's the quick one-sentence explanation is a mechanism to secure web requests made in a browser. And it sort of has some implications on making requests. And if you start to mess around with fetch more, you're probably going to run into them. So I wanted to sort of go over it so you have a rough idea of what's going on and maybe some suggested steps going forward to troubleshoot those issues. Okay. So these are the list of all the headers we're going to talk about today. Content type and accept. So content types either in the request or the response. It can be in either, and accepts just in the request. Authorization is a request header. Location is a response header. Host is a request header. Custom headers, you can put those wherever you want. And the access control headers are request and response, and those are for CORS. And we'll touch those on the very end. Okay, so our first header is content type. Think of this as like a file extension. It sort of tells you the type of data that's being sent in either a request body or a response body. However, it doesn't actually use like a couple character thing like a file extension does. They've got their own sort of way of indicating the type of data. And it's this thing called a MIME type. It's kind of this string that's like a bunch of sort of words with like slashes separating them. So a few examples, text/plain. That's a MIME type that means a plain text document. Application/PDF. That's a MIME type that means the data in this request is a PDF. So like you uploaded a PDF and took all the data inside of that PDF and you included that in your request body. Or image/PNG. That's a MIME type that's used if you're going to be uploading a PNG. Or similarly, if you're downloading these things, let's say you make a request and you get back from in the response a PDF. You can have a content type header in your response that defines the type of that response to be a PDF. And if you're going to do that, you would do content type application/PDF. Same sort of thing with the image. And if you have if you don't know what the content type is of your thing, you just want to be like, this is just data. Like I just want to sort of have like a content type that can mean anything. The most generic content type is application octet stream. Now, let me unpack that. Why octet stream? Well, so the application prefix, a lot of the MIME types start with that. You sell it with like application PDF, but octet stream. So this may or may not, I don't know how familiar you are with some of this stuff, but computers store things in bits and bytes, and that's sort of how it manages data. And a byte is made up of 8 bits. Octet stream, 8 oct. So it's sort of like streams of octets. Octets are sort of another word for a byte. Often it's used more in the context of like sending network data. So it's sort of saying like, this is a set of bytes, a set of a bunch of memory, and we don't really know what it is, but it's like a bunch of that. So that's kind of unpacking that term a little bit. Let's dig a little bit more into MIME types though. What's going on here? Well, MIME stands for Multi-Purpose Internet Mail Extension. And sort of like I said before, it serves a similar purpose as like a file extension, but it's not used for files. It's used for like data sent over networks usually. So you send a bunch of data from one system to another system, from a client to a server, and somehow you need to be able to identify what type of data that is. And the way you typically do that is with a MIME type in networking. There's a big list of all the MIME types on Wikipedia. There's something where like this is like a thing where new ones are always getting made. So realistically, there's probably ones that aren't on this list. Wow, come on. There we go. But you can go through here and take a look at a bunch of the ones, and it'll sort of kind of go into way more detail than you need to. Okay, it's actually not going to give you all of them. It's going to give you a bunch of common ones. Well, whatever. But you can see here, like some of these probably look pretty familiar, like application JavaScript. If you wanted to send JavaScript in your document, or send it back in a response from the request, you could do that. Another one, maybe like PNG or JPEG. So those are for images. Text CSS, if you're responding with CSS in the response, then that would be your content type. Text HTML for HTML. So there's a lot of these. But these are some of these you'll probably end up memorizing with time, but they're not as important to memorize as some of the other things we've talked about so far. Yeah, so that's content type. Our next header is accept. So accept is very similar to content type, which is why I sort of lumped them together in the list before. Accept is a header that is only set in a request, and it tells the server what type of data that the requester would like to receive in their response. So here's an example. Let's say I'm making a request and I'm sending a bunch of plain text in my body. I'm making a post request, and I set the content type header to text plain. Let's say as a response, I want to get back a PDF. I can send the server the header of accept application/PDF. And if the server's sort of doing the right thing, it should give me back a PDF. Now, it's worth mentioning that this isn't like a guarantee. This is more like telling the server, I would like to get this back. The server could just give you back something else. Like, there's no like guarantee you're going to get the same thing back that you requested. But where this is helpful is sometimes you'll have systems that can handle data in multiple formats. So content type, you can specify that to say, okay, my data I'm sending in is plain text. Or you can say the data I'm sending in is a CSV, or the data I'm sending in is an image. And sort of one URL, one endpoint can handle all those different types of data and do different things with them. And then you could also say maybe it outputs different formats as responses. So maybe you're sending it some text and sort of it can give you back an image, or it can get like a PNG image or a JPEG image, or give you back a CSV or a PDF. And you can sort of specify that accept header and sort of tell it what type of data you'd ideally like to get back. Now, you might be wondering, in practice, how much does this actually happen? Not all that much. This is one of those more like idealistic things where in a perfect world that you would sort of handle this. In practice, things tend to transact in one type of request body and one type of response body, but it exists and it's a good thing to know about. Cool. Okay. So here's sort of an example of how this would, oh, our trail.
Just one quick question.
Yeah.
So if the default MIME type we get back is the octet stream, is that typically in a text format?
It can be. So it's worth mentioning that when you're sending data from one computer to another computer, behind the scenes, you're sending binary data. You're sending lots of ones and zeros. Okay. And that binary data, sort of you take every 8 of those bits and you group them together into a byte, and you sort of have like that's sort of your unit of measurement. 1 byte is 8 bits. And if you do the math, there's 255 possible combinations of ones and zeros, or actually 256, but they go from 0 to 255. So what that means is you can store 256 values per like byte. And it turns out in some of the more primitive character encoding sets, that's how you use 1 byte per character. So behind the scenes, when you're sending text, you're actually sending streams of bits or streams of bytes. But it's just sort of how that stream of bytes is being interpreted. And what you're doing with content type or accept is you're telling the other system how to interpret that stream of bytes. And with text plain, you're saying this stream of bytes is text. With octet stream, you're saying this stream of bytes is just a stream of bytes, and I don't know how to tell you what to do with it, so do whatever you want with it. Does that make sense?
Yeah, I guess it's almost like it's undefined in some ways.
Yeah, Totally.
Okay. All right, that makes sense.
Cool. In practice, you don't see application octet stream all that much. Usually the header will just be omitted or something like that, but it's a thing you run into occasionally, so I just wanted to throw it in here.
All right.
That's going to kind of be the theme for today. Like a lot of these headers, you won't see always, but I want to sort of make you aware of them, so when you do see them, it's not a total surprise. This is sort of like how the exchange would work here, where sort of you make your requests. This is sort of with the netcat example here, but you could sort of abstract that with curl or fetch or postman or whatever you want. But you connect to it, you make your request, you specify a content type of text plain and accept the text HTML. And then in my body, I sort of include my plain text. And then back in the response, I get a content type of text HTML, which lines up with my accept header. And if the server is behaving properly, the accept and content type headers should line up. Okay. Oh, what am I saying here? Oh, I just gave you another example. Okay, so yeah, I mean, I could do it. So if let's say I made that same request, but included an accept text plain header, I might get back plain text instead of HTML, ideally, if the server is working properly. I'm probably beating a bit of a dead horse here. I don't know what I meant to do a demo of here, so I'm just going to skip by this. I thought I reviewed this morning and I got rid of that slide. Okay, anyway, next header, authorization. So the authorization header is a standard location by which you can put information that identifies who the requester is. Why is this important? Well, sometimes you have things on the web that you want to only allow certain users to access. Imagine like some sort of like social media application. In order to make a post in the application, like to create a new document that like contains like information, like a tweet or a Facebook post or whatever, you need to be logged in. You need to have you need to have a user to associate with that post. And you need to put that somewhere in the request to make that post, or else the server doesn't really know who's making it. So the authorization header is the most common way this is done. And the way the header is structured, so this, and I should say, this sort of goes against what we did earlier this week. Like we used it very briefly, and I used it more as just like an example, but it's actually a little more complicated than how we used it earlier this week. So there are two sections to it. There's two words. The first word of the value is the scheme, and the second word is the value. So the scheme, there's a bunch of different sort of mechanisms by which you can use to identify a user. The most common one is called bearer. And we're going to talk about two of them, basic and bearer, today. But both are ways by which you can sort of identify a user. Oh, okay, before we go into that, let me sort of give you an example of how this roughly works here. So the first scheme, basic, this allows you to specify a username and password. So imagine with every request, you specify a username and password, and sort of you're like almost like logging in when you make the request. Like the server receives that request, takes a look at the username and password, makes sure it's valid, and sort of does all the sort of stuff it needs to do there. And if that works, then it does the thing you want to do. And if it doesn't work, then it will give you back usually a 401, which is a 401 unauthorized. Notice it's a 4, starts with a 4, so it means you screwed up, you need to specify a thing. So 401 unauthorized tends to mean your header, your authorization header is incorrect. As an aside, the way that the basic auth mechanism works is a little bit goofy, the way it actually encodes the data into the header. It uses this technique called base64. Has this been brought up before, base64? Does that ring a bell to anybody? Probably not. Okay. So base64 is sort of a mechanism for encoding data. So you can take data, put it through this function, this base64 function. It gives you out sort of like some data that looks garbled or different. And then you can sort of put that back through another function, sort of base64 decoding function, or it'll give you back out sort of the original text. Now, base64 is an encryption. It's sort of just like a different way of representing the information. Let me show you sort of what that looks like. So I'm going to open up a JavaScript console real quick here. I'm just going to type in here. There's two functions of JavaScript that sort of go back and forth between different base64, like encode and decode. The one to go one way is called B2A. They have really awful names. Oh, actually, it's A to B. That's the one I want. A to B. And I can sort of give this a word. I'm going to go like hello. Oh, wait, it's B to A. See, they have such bad names. I always forget which one goes in which direction. I just try it, and then when it fails, I do the other one. So B2A, that gives me this. And if I take this and I call the other one A to B and give it this, it gives me back hello. So this is like a different way of representing data. Why is this cool? Like, what's the advantage of this? Well, base64 uses, when you're representing that data, only uses a small character set. So I can type whatever I want in here, like whatever characters I want, like as many crazy symbols as I'd like. Maybe I'll put a couple numbers in there. And we're always going to get out is going to use the character set of lowercase a to lowercase z, uppercase a to uppercase z, and then plus and equals. It'll only be encoded using that data. And that's really nice because if you want to send data in a request, you like can't just stick like random characters all over the place, like because they might mean things. Like imagine you wanted to sort of include like a slash as like part of a URL, but you didn't want it to be like a separator. Or you wanted to include I don't know, like a colon in a header name or something like that. Like those are things where if you try to do that, it's not going to work quite right because the data, like that sort of means a thing in the protocol. So this base64 encoding is like a way that's often used in requests to sort of take data and convert it into a smaller character set in a way that so you can sort of fit into the way the protocol works. This is kind of an aside. This isn't all that important for what you're going to be doing for the rest of this class, but I want to bring it up because it's a good tidbit, and base64 will come up. And the way that it's sort of used with the basic auth mechanism is to generate a basic auth header. What you do is you would do authorization, basic, space, and then the value is the username colon the password base64 encoded. So username colon password base64 encoded to be this thing. And then to make my header, I go like authorization basic that sort of thing. Should make it a little bigger, sorry. And that would be your header. And what the server will do is it'll look at this header and we'll go, oh, the beginning part of the authorization header is basic. So I'm going to use the basic authorization scheme. And it's going to take this, and it's going to take this, and it'll decode this. It'll go A to B that. And it'll go, oh, okay, cool. And then we'll take this and it'll split that based on the colon and go, oh, okay, there's my username, there's my password, done. And then it will sort of do whatever it's going to do with those credentials and either let you in or give you a 401. So this is sort of one mechanism by which you can provide authorization. Does that make sense?
I need to hear that again, please.
Okay. Yeah. So
Like the part about, those last few lines.
yeah. So the authorization header, when specified with the basic scheme, takes this sort of crazily encoded thing here, this sort of this sequence of characters. This sequence of characters contains the username and password combined together and base64 encoded. So to get the username and password out of this thing, you can base64 decode it, which uses in JavaScript this like weirdly named function. But this is a function that takes base64 and decodes it to be whatever's inside of it. So this string here decodes through this function into this username colon password string. And this string now, because it has those sections, the username and the password, the server can sort of extract out that username and password bit and use that to sort of verify that you are who you say you are. Sort of check to make sure your username matches what it expects, check to make sure the password matches what it expects. And if it does, then you're good. And if it doesn't, it'll give you back a 401.
Okay, that's better.
Okay. The base64 part is a little bit weird. Like that, I think, is probably what is anyone who's confused is probably the part that is the most unusual here. And it's sort of just kind of like how it works, and it's kind of unusual. But in concept, if I undo the base64 encoding part, this is sort of what you're sending. Like a header looks like this. It has this stuff in it. It's just this happens to be represented in a weird way, represented as this thing. Artrell, you've got your hand raised. How can I help?
Just want to make sure I'm understanding the concept correctly.
Mhm.
So when we do the B to A, we are encrypting what's basically kind of like in that string, right?
Yes.
In a way.
I'm going to just correct you slightly. Instead of using the word
Okay.
encrypting, maybe using the word
Okay.
encoding instead. And there's
Thank you.
an important distinction there, but it's not all that important right now. But continue. Sorry.
Okay. So it's encoding
Yep.
it. So whatever it's written in it, and it sends it back. And when we do the A to B, it decodes.
Yep. Decodes.
Was in it. All right. So, and the examples and the closer lines, which says username and password, it's encrypting those two particular words. But if we put like a real username and real password in it, that's what we would get back.
Yes. So let me do something like real username, real password, or whatever. You sort of know what I mean by that, I think. But
Right.
notice how when I get back here is different than what I got before. So this sort of contains this information now. And if I were to send this to the server, it would now know that this contains real username and real password instead of username and password.
Mm-hmm.
Let me quickly touch on the whole encode versus encrypt thing, because I think this is not a in practice for your understanding, this isn't that big of a deal, but it's something I want to bring up because it is going to be important later on. So base64 is something where I can give anyone a base64 string and then they can decode it. There's no sort of like special information you need to be able to decode a base64 string. And that's why I'm using the phrase decode and encode instead of encrypt. Encrypting typically means you have information that sort of is obfuscated in a way that it requires special information to decode it. Like you sort of need like a secret password to get in the speakeasy bar. This is more like if you knock on the door, they'll let you in, and they'll let anyone in. And you don't need a password. It's just like you just need to sort of know how to like walk up to the door and knock on the door. Like there's no sort of special information needed to extract the information out of the base64 encoded data. And that's sort of what's the difference between encoding and decoding and encrypting and decrypting. I forget if it's still covered in careers in code. I think it might be. There might be a security module later on. If it is, you'll talk about encrypting in more detail. If not, though, when we get near the end of the class and you're curious, we can chat about it at some time at like an open hack or something. Cool. So I explained all that, but I also want to give you the caveat that basic auth is not going to be used as much. Like it gets used and I want you to know about it, but like for the rest of this class, we're not really going to use it. I just want to expose you to it. It's kind of the theme of today. I'm exposing you to a lot of things here. The thing that gets used more often, though, is bearer auth. So instead of the first word being basic, it's the word bearer. Bearer auth uses what's called a token, which is a different sort of way of providing identity information. So before with basic auth, we used this sort of string that was like an encoded version of our username and password, effectively a different representation of that data. Bearer auth, you use a token, which is sort of a completely random string. Usually it looks kind of similar to base64 data, but it's different. It's like completely random. It doesn't decode into anything. It has no real meaning. And why is that important? Well, I guess regurgitating my slide here for a second, like it's a unique identifier that's pre-generated by the people who run the server. So the server people will give you this random token, often out of band of the server. Like they'll sort of like email it to you, or you'll find it in like a web dashboard somewhere and you can sort of copy it and download it. And this token is sort of linked to your user account. And then when you include that token in the request, it's sort of saying that this request is associated with this user account. And sort of anything that this request does should happen in the context of this user. So like a great example is, let's say we want to go back to like the social media post thing. Like if you make a post and you include this authorization header with a token that sort of is matched up with your user, when you make that request, it might make a post where the poster is your user. And if you don't include that information and you make that request, then the server is going to be like, well, okay, I want to make a post, but like I don't have an author to go along with this post, so it might give you back a 401. A few different places that this sort of information is used. Authentication, so sort of what I just talked about, ensuring that you can only access information or do things with information that you have permission to see. Like another great example of that too is like, let's say there's a list of like, I don't know, a list of things, and you only want to allow some users to view one set of the items in that list of things, and another user might be able to view the whole list. So sort of this concept is like permissions, a common thing that comes up where like you have some users who can only see some things. Like this is another case where like this header would be important, because if you specify this header, you know who's making the request, so you know sort of what information you need to omit from the response. Another place I guess, yeah, permissions. I'm just saying all my slides a different way this today. Another case is rate limiting. So rate limiting, let's say you run a server and you are allowing lots of other people to make requests to your server. But there's someone who's a real jerk, and like 10 times every second they're making a request to your server. And they're using up like 50% of your server's sort of bandwidth. And you're just like, this is insane. I don't want to deal with all these requests. I want to like more equally distribute the requests that everyone can make. Well, one thing you could do is you could require that every user has a token. And if you do that, then you sort of know, okay, each token lines up with a certain user, and you can sort of keep like a counter for each user. And every time they make a request, you can sort of increment that counter. And when that counter gets above a certain number, you can be like, you've been cut off. You can't make any more requests. And this sort of allows you to ensure that like a user can't make tons of requests and sort of take more than their fair share of resources. Usually the way a rate limit will work is sort of you'll have a certain number of requests per time interval. So it'd be like that counter would reset hourly or something. So every hour you can make like 100 requests. And if you try to make more than that, it won't let you. And then if you do go over that rate limit, you have to wait an hour before you can request again. This is a common thing you'll run into when you're interfacing with other people's servers that you haven't written. So yeah, okay. So sort of an example here of this being used is if I was a client making a request to a server, I might include this authorization header with a bearer scheme and with the token. Let's say my token's just the phrase my token, or that sort of text, but in practice it would be some random letter or number character combination. And that is a good token, then the server will give me back a 200 usually, or some sort of status code that begins with a 2 because things went well. But on the other hand, if I gave it a bad token that sort of was not a valid token, it'll give me back a 401. Sometimes it'll give me back a 403 too, but usually a 401. And this means the token's bad. Starts with a 4. There's a problem on your end. You need to sort of correct that, and sort of the server won't handle your request until you get a valid token. Now, one other aside I want to mention, because this will come up a bit later on in this week, but sometimes a token isn't in the authorization header. So, like, if you're going to use a token, the best practice way is you specify in the authorization header the scheme of bearer. But not everyone does that. This is more of like a good rule of thumb that makes your API predictable to use, but it doesn't always happen. So because some servers don't do this and they sort of specify it differently, like don't think that you can always do this and it will always work. This is where looking at the documentation for the service you're interacting with is really important, because that'll tell you where you need to put that header. Sometimes that header goes, or sorry, that token. Sometimes that token goes in like a different header. Like maybe there's like a special header called like special authorization or something. It's some sort of different header, or like maybe a header called token or something. Some people do weird things there. Sometimes it'll go in like a query string parameter. Sometimes it'll go in the body. There's a lot of different places it can go. Generally, though, the header is like this authorization header is sort of the standard place where it goes. Okay. Before I move on, any questions I can answer? That's all we're going to talk about around authorization. Okay. We're going to generate tokens a little bit later today, so we'll get a chance to sort of give this a try with a token. And so that's coming soon here. Okay. Location. So the location header is used in two special cases. You probably noticed when we were talking about status codes before, I talked about all the ones that start with 2, all the ones that start with 4, and the ones that start with 5. We didn't talk about status codes that start with 1 or 3. Well, maybe you've noticed that, maybe you didn't, but if you didn't, I'm calling it out now. I didn't talk about those, and there's a reason I didn't talk about those. There are some status codes that start with 1, but they're not used all that often. I can only think of one off the top of my head. And we're going to sort of skip over them. The ones start with 3, though, we're going to talk about today. There are 2 status codes that start with 3 that are worth knowing. 301 and 302, and they do what are called redirects. So let's sort of think through an example here. So let's say I make a resource on my server, sort of a path, an API endpoint. These are all sort of words that mean kind of the same thing. I make sort of a location that you can make a request to. And I set that up, and it's great, and people are using it. And then I decide, I really want to move this. I want to change where it's located. So what I do is I update the path, and now it's sort of in a new path, and I send out my changes, sort of it's all deployed and going. And then someone sends me a message, and it's like, wait a second, this old request I'm making isn't working anymore. Like the path, it's giving back a 404 now. This path doesn't exist. And I say, yeah, that's what I expected it to do. And the person's like, but I really want it to work with my old stuff. I don't want to have to like update my code. And I begrudgingly am like, okay, fine, I guess. So it turns out this is a common enough use case where you sort of move things around and sort of want to ensure that old URLs sort of still work, that there's a thing built into the protocol HTTP to handle this. And what it is if you get back a response from an endpoint that starts with it's a 301 or a 302, these are what are called redirects. And a redirect effectively means that you made a request to this URL, and you get back this like a 301, and it says, actually, instead, I want you to make a request to this other URL instead. The thing moved. So behind the scenes, what will happen, your HTTP library, so like curl or postman or fetch, we should do this behind the scenes, will make another request now to the new thing that came back in that response with the 3 whatever status code, the 301 or the 302. And it will sort of make that behind the scenes and do that transparently. And this is really nice because it means if you move things, you move resources or move paths, then clients don't have to, oh, what just happened there? Okay, reload. Let's see what happens there. That's never happened to me before. Well, whatever. But if you make a 301 or get it back a 301 and 302, it'll transparently redirect behind the scenes. And the way that it knows where to transparently redirect to is there's a header that gets returned in the response for 301 and 302 redirects called location. And that location header contains the place to redirect to. So we're going to go through an example here to sort of show you what I mean. Let's say I'm making a request to example.com on port 80, and I make a GET request to /first, okay? And then I get back in the response to that request a 301. 301 moved permanently. And this 301 has a location header of example.com/second. So then behind the scenes, what my system will do is it will then connect back to the server again and now make a request to second. And sort of this is how it knows, that location header is how it knows where to make that follow-up request to make sure it's doing that redirect transparently. And now in the response back again for the second request, I'll get back the data with that is sort of supposed to be, was originally located at that first path. But because of the redirect, now sort of it will automatically go to that second path behind the scenes. How am I doing? Does this make sense? Cool. I'm trying to come up with a good analogy here about something that's not a software example as to where this applies, but I'm coming up with a little blank, but I'll keep thinking about it.
Okay.
Um,
So far, we've got a request to a server using get.
Mhm.
And we want it to come back as a text HTML form. But we get back that 300 and the server was moved permanently. Is that what moved?
the path
The
was
path.
moved permanently. So usually this means the path or the location that this data is located at on the server has changed.
Okay.
So-
would, for example, be like the mail post office when you do an address change?
Exactly, that's a really great one.
The
Yeah,
letter
so
address, and then they take it back and then they send it to your second address.
exactly. Yeah, that's totally what happens.
Cool.
And that actually works really well with my first day analogy too. Oh, nice. I'm like really pleased with myself how well that first day analogy has tended to like track through all the complexities. Like it's been good. Thank you. And using that analogy, what's the difference between a 301 and a 302? A 301 is like a permanent change of address. Like you moved and you're never coming back. So what this means, if you do give back a 301, the local client will actually cache that. It will sort of store that locally. And then if you try to make a request to that again in the future, it won't actually even make a request. It'll just be like, oh, that's on my list of things that move. So I'll just make a request transparently behind the scenes of the new thing. So that's what a 301 does. A 302 means it's a temporary redirect. And that means it's sort of like it's a temporary change of address. Like maybe you moved, but you're coming back later. And why that's important is because of that caching side effect where, and we're going to talk about this a little bit in a few days, but there's a lot of sort of behind the scenes caching that happens in HTTP, sort of like keeping track of information locally to try to make the protocol faster and try to make requests faster. Like if you don't have to make a request, that's way faster than making a request. So being able to sort of store that 301 locally and know that, oh, this path no longer exists can be kind of a speed boost. But in practice, they do the same thing. They both use the location header. So they that caching is kind of like a footnote. They act the same as a user of the protocol. Cool. Any other questions before I move on? Okay. Host. So if you can't tell, this is just a big list of headers, and we're just rushing through them all. And yeah, like that's sort of what the beginning part of today's, or the first half of today is going to be. So the host header defines the original host name that the user made a request to. So let's say you open up your connection to like example.com and you make a request to /. Most HTTP clients will include along with that request a header called host that maps to the host name or like domain name that you made a request to. You might be wondering though, why is this important? Like you already specified this once. Why do you have to repeat it again? Well, there's a really good reason. And that's that when you make a request behind the scenes, if you remember sort of back to day one, we talked about that whole DNS thing. So you make a request, and what it'll do is it'll take that DNS name, that host name, and it'll look it up and get back an IP address. And then it will connect to that IP address and send it that information, whatever the request information you're sending. Notice, though, that behind the scenes when you're doing that, you're not actually ever sending that original DNS name onto the server. Like it's as if you're connecting to the IP address. And if you do like, let's say that example.com like resolves to be this IP address here. There's no difference from the server's perspective between running nc IP 80 and nc example.com 80. Like the server is going to see in both cases, oh, a request came in from this IP address out there on the internet somewhere. And it just knows a request came in, but doesn't know like what domain you requested. And this, it turns out, is sometimes really important information. Yeah, okay. So the actual host name never makes its way into the original request, only the IP. And there's no way for the server to figure out that you visited example.com. Another sort of case here, let's say I have another domain like test.com, and test.com also resolves to the same IP address. like if I make a request to test.com and make a request to example.com, the server can't tell which one I made a request from. From the server's perspective, they're identical. So this is why the host header is kind of important, because it includes this information in another place. So the server knows, oh, this request came from this domain name. Yeah, so hackupstate.com, careersencode.org, let's say they sort of both post the same, redirect to the same server, or sorry, they both resolve through DNS to the same server. Got to use my terms right, because we just talked about redirects, and that's super confusing. So if they, like, sort of taking that out of the client side of the picture for a second, like if the server's receiving 2 requests and they're both in the same IP address, like the host header is the only way it knows where they came from, or like what domain the user requested to get them. Okay, and why this is like, I mean, I'm saying all this, but you're probably still like, okay, but like, why does that matter? Like, and the reason why it matters is, in order for servers to really be cost effective, it's very unusual for a server to sort of handle only one website. Usually, servers handle many websites or many web applications. So if you have one server that's receiving like requests from multiple applications, like how could you handle that? Well, one thing, you could run them on multiple ports. That's done pretty often. So you might have like this running on port 80 and this running on like port 81 or something, and they're sort of different ports, so sort of different applications, and that could work. But the tricky part with that is that means that in order to go to it in a web browser, you've got to go to like hackupstate.com:80, hackupstate.com or careersencode.org:81. And if you go to hackupstate.com:81, you're going to get back the careers and code stuff. So like, it doesn't really solve the problem, but it's like a workaround. So if you include this host header, though, now you can actually do it sort of how you want, where like, if you make a request to this IP with this host header, you know, oh, I need to serve back the hackupstate data. And if you make a request to the same IP with the host header set differently, you know, oh, I need to send back the careers and code data. So that's sort of where it comes into play. The reason why I'm bringing it up and where it might be a thing for you all is sometimes if you make a request, you need to be able to, and you don't include that header, you might get back weird stuff. And if you're making a request with netcat to like something like a actual server, not like my careers and code.ml server, and you don't include a host header, it'll probably be like, give you back a 400 of some sort and be like, you need to give a host header. I need to know from what you're like what domain you're requesting here. So that's why I'm mentioning it, because it's another one of these things that comes up that is good to know about. But whether you're going to run into it day to day, probably not. Does that make sense? Anything you can do to clarify that some more? Okay, cool. So next we're going to talk about CORS. Now I'm going to leave this a bit of an option open to you all here. Would you like to do the exercises for this first section and then come back to CORS, or would you like to do CORS all as one, like this whole thing all as one go and just do all the exercises at the very end? Any preferences? Okay, I'm going to say let's do the exercises now. And probably by that point, we can take our break after that. I think probably our break might be a little bit early today. And then when we come back, we'll do CORS and we'll separate it out that way. So should have organized my slides that way, but I think yes, okay, cool. So this is our first exercise here. You can do this in any sort of, you can do this with curl, this fetch, with postman, whatever you want. Probably it's easiest to do it with postman, but you know all 3 tools now, so you're welcome to use whatever you'd like. But the first thing I want you to do is I want you to make a request to this path on your own here. And when you make a request to this path, you're going to get back a token. So this is sort of where we're going to start using tokens. This is a little authorization header example here. So give this a shot, give you a few minutes, and come back here and we'll sort of go down to the next step. So to do this successfully, you should get back a 200 with a token in the body.
What do you want us to do when we got the token?
That's step 2. We're gonna get there in a second.
Okay,
So 30 more seconds or so, and then we're gonna jump in and do that.
okay, sorry.
No problem. Okay. So I'm assuming probably most of you have gotten a token by now. This should be pretty straightforward based on what we've talked about so far. I'm going to, though, get this up and sort of follow along just so I can be ready here for the next step. So I'm going to make a new thing here. I'm going to go.
Hey, I just finally found my screen. I didn't get it. And
Didn't get it.
I just missed where you said we should find this information. Like the
So
examples that we were supposed to use.
I'm not sure if I understand what you're asking, like how you're supposed to make the request.
Yeah. Mm-hmm.
Make it with Postman. Probably that's the easiest way. Yeah, and it should just be a pretty much straightforward post request to careersandcode.ml/tokens. You should get something like your token was created. It's this thing. So
Hey, Jennifer,
generally,
if you, I'm sorry, go ahead,
ahead.
man.
No, go ahead.
I was just gonna remind Jennifer, there's also the, if you have your VS Code, if you can pull it up from yesterday, we did a version of it in VS Code using like an index HTML file and using Go Live. So that might look familiar because that's how we did it yesterday, I think.
Okay, cool. Wonder, did my Postman go away? No, it has to be here still.
Oh, Artrell.
All right, when I first tried it, I had a little bit of difficulty. After tokens, I put a space and then an 80, and I didn't get the correct response. Is that because the 80 is the default port?
If you're going to add a port, you have to add it after the domain name here, not at the very end.
Okay. I did the space like a dummy, and then I did 80, and I got back something different.
No problem at all.
All right. Thank you.
Cool. Yep, no problem. Generally, so let's talk about a bit of token hygiene here. Tokens are a credential. It's a thing that identifies you to a server. Treat them like a password. It's not something you want to share with people. You don't want to sort of take this and like give it to your friend, because then sort of your friend can act as you to the server, you know? Like, so it's the sort of thing where, like, for what we're doing here, these tokens are all stored in memory on the server, and there's nothing important on the server this is going to give us access to. So, like, I'm very cognizant that I'm being recorded right now, and someone could look at this token on screen and do whatever they wanted with it. But, like, in this case, these tokens are kind of like toy tokens. They don't actually do anything real. But what is worth bringing up here is, like, if this actually did something, like, could be a credential that could allow you to do something very dangerous. Like, for example, delete something on the server somewhere, or have permission to like look around or snoop around, or so it's like the sort of thing where you want to be sensitive what you're doing with this. But I'm gonna take this and I'm gonna copy to my clipboard. So just
Are tokens randomly generated?
they tend to be, yes. I'm using that phrasing because they aren't always, but in most situations we run into, they are. So this data doesn't really mean anything. It's like effectively a random series of ones and zeros converted into text. So I've got my token here. Let's go on to the next part here. So with this token, I'd like you to make a request to /protected resource using an authorization header with a bearer token with the token we just generated in it. And if you include that header properly, you should get back a 200 response code with some text in the body. And if you don't include it properly, you should get back a 401. And I sort of want you to try out both of those cases. So make a request to /protected resource. So still careers and code.ml, still port 80, all that sort of stuff's the same. Only this time, include the authorization header. So do that. And then try to make that same request again, only the second time, don't include that header. I want you to sort of see what both those look like.
Okay, so Ryan, can I share my screen with you and get some help?
Yeah, go for it.
So I'm trying to look at the examples, but I'm not understanding how we got the token.
Yeah, so there's two things I noticed they're a little bit off in what you've done, and they're both in the URL. So you've got http://careersandcode.ml space 80. If you want to include a port, it's got to be :80, not space. And the other thing you need to do is if you take a look at the slide, the path you need to make a request to is /tokens plural, not tokens singular.
Okay,
I bet
could
if you hit,
you tell me which slide that was?
yeah, that is slide 199.
Okay.
Wait, that's is your slide different than mine? Wait a second.
There's a space, so that confused me.
What the heck? Our slide numbers are different. I don't get it. Let me share my screen and show you the slide I'm looking at.
Okay.
If you go to right before section 6, sort of tomorrow's section, and you go a few slides from that, this is the slide I'm looking at. I'm not sure where our slide numbers line up, but the fact they don't makes me very worried that something's messed up with this presentation. It's this slide though, which for me is slide 199, and it's a few slides up from.
Ryan,
Yeah,
did you, by any chance, did you add like any slides or anything since last night?
I don't think I did.
Okay, because when I signed in, mine gave me an alert like this is not the original document. The document is changed or whatever, and I refreshed it and I didn't see that, so I didn't know. I took it to mean like since I hadn't refreshed it, since you might have changed something, it might see a conflict there.
Yeah,
but barring that, I don't know why they wouldn't match up. That is weird.
Yeah, I don't think I did. Maybe I did though.
So then I have the generated token. I'm just gonna put that into Postman.
That's where the /tokens plural path is right here.
404 not found. Huh.
Share your screen. Let's take a look.
Yeah. So you said it has to be ML:80.
Yep.
Hmm.
Then /tokens.
Tokens. Yeah.
Yeah. So the other thing you got to do is, I wish we could go side by side with these slides, but you need your method to be post. That was also on the slide.
Oh, geez. Okay. I was looking at an older example and I thought that that was the one to follow.
Okay.
Okay.
Cool. If you click send, that should work though. Yeah, there we go.
Okay. All right, great. I'm gonna move on.
Cool. I'll share back where we were before, just so we can reference that here.
So I'm sorry, I don't mean to interrupt, but
Yeah.
when we're completing this on Postman, do we take the token that we copied from the previous example and post it in the token section
Yes.
and just press send?
So you want to include it in a header. You don't want to put it in, yeah, yes. Sorry, I misunderstood what you said. You're right. You're right.
Okay.
Yes. Took me
Okay,
a second there to process that.
okay, perfect. All right. Thank you.
Yep. No problem. In general, like sometimes you will get headers by making requests to servers, but at least for what a lot of you folks are going to be doing, it's more often that you'll get a token from like a web page somewhere. Cool. Artrell.
Yeah, I need help.
Yeah.
All right. Let me, if I can share my screen and I'll show you what I was trying to do, then you
Sure.
can help correct me.
Yeah.
All right. So what I was trying to do, I was, so where am I? I had, okay, so up top, I'd had queries I call and protect the resource. Then, I went over to headers, I did authorization, then bearer, then the code, then I got, you gotta use this. So now I try to click on authorization, but I'm obviously not doing something right.
Yeah, so I do want to mention one thing real quick, and that's that there's that tab authorization in Postman. And that's a little confusing here. So behind the scenes, that does set the authorization header, but that does some fancier stuff, and we're not going to use that for this class.
Okay,
So ignore that tab. It's super confusing, but we're going to go to headers and set the authorization header manually.
okay.
Now, looking at your example there, I notice you've got two headers you've added. One that's with the name of the header is bearer, and then your token, and one where the name
That
of the
didn't work, so that's why I went to the next, the below one.
Okay, yeah, cool. So the one below is very close to being right. If you take a look at the format though of their value, there's one little deviation you have there. If you take a look at let me find, well, I should give you a slide number. Let's see if the slide numbers work for you. Slide number. Like try 167. Yeah, okay, they work for you. So that's sort of the format of an authorization header with a bearer token.
Okay, so I should basically get rid of that colon then.
Yep, exactly. Generally, you also want to capitalize your B in bearer. Oh. If you could get rid of those other two headers you had there, you've got a bunch of stuff there. If you just uncheck them or delete them or whatever you want to do. Generally, if you send multiple of the same header in a request, sometimes things get a little confused. So I bet if you hit send now, though, it'll work for you. Yeah, there we go.
Got it. All right, thank you.
Yeah.
So, Nate, I actually did exactly what you told them not to do. I went in the authorization, and then in the drop down under type, I put bearer token, and then that's what I meant by, do I put the copy token under token, because this it literally gives you the space to
Yeah.
post it and send it. But I got the same. This is a valid token. Thank you.
Yeah. So
So
if you go over to the headers tab, you'll see that it automatically wrote an authorization header in there for you based on what you
okay.
entered in the other tab. So like the reason why I said not to use that is more just that it's not going to give you as much flexibility, and we're focused on learning right now.
Okay.
And it's good to sort of type it out by hand. But
Okay.
like in general, like sure, you can use it. And you'll actually see in there for the scheme, there's like a lot of them. And a
Mhm.
lot of them that we're not going to get anywhere even close to covering in this class.
Okay. Okay, cool. Yeah, I'm sorry, but
No,
I
problem.
didn't know what else. Okay, cool.
Yeah. Can I get some thumbs up or thumbs down and reactions to sort of see how folks are doing with this? That's some middle thumbs, some thumbs ups.
Yeah.
Okay.
I guess I got it, but I didn't really understand how. I just didn't see the example in the slides. Like I was just reading bearer token. I didn't know it had to be a part of the value that we put in.
Ah, okay. Yeah, so that's where I mentioned sort of the format of the authorization header goes scheme space token, sort of like it's formatted in that way. And that allows you to sort of specify whatever scheme you want. So you can do a basic auth scheme, a bearer auth scheme, and there's a lot of them. It's just those are the two we're going to talk about today.
That's the scheme. Okay. That's where it connects. All right, well, I got it right.
Cool. Exona.
Oh, I didn't mean to. I meant to put a thumbs up.
Oh, okay.
Sorry.
Cool. Sounds good. Schneider, I saw you do a middle thumb. Anything you want to chat about, or just gonna take some time to absorb it?
Take some time to absorb it. That's how I usually am. Like I'll get the gist, but I don't really understand it
Cool.
completely.
Yeah,
Yeah.
fair enough. We'll have a lot more practice with this later this week, especially on, I guess it would be Thursday. Yeah, Thursday. Okay. Let's go to the next one here. Share screen. Cool. This one's got a lot of text in the slide, and I apologize. It's not actually that complicated of an exercise, but there's just a lot of like preamble. These header ones, just kind of how this goes, because sort of like without some of what we're going to talk about tomorrow, I have to still do some contrived stuff. Tomorrow, we're going to talk about a really important thing that's going to sort of unlock the ability to sort of talk with like real stuff. But we're not there yet. So there's an endpoint on the queries.encode.ml server at post/image upload, image-upload. And my goal for you is I want you to upload an image to that endpoint. And you need to sort of, it can be whatever image you want. It can be whatever format you want, as long as the image or PNG or JPEG. Those are the two ones that I support right now on my server. But it doesn't matter like what's in the image or anything. This is probably going to be easiest to do in Postman. It's doable to do in all three, but we haven't talked about sort of how to do it in curl or fetch as much yet. But the idea is I want you to upload a file, and I want you to make sure you set the content type header of your request to match the MIME type that goes along with your file. We talked about sort of the MIME type for PNG and JPEG earlier. Image/PNG and image/JPEG, JPEG, not JPG. That's really important. But if you look up what is the MIME type for JPEG, the internet will tell you. So that's what I'd like you to. Actually, this is not true anymore. So that's what I'd like you to do to give this a shot. And let me show you real quick how you upload a file as the body in Postman. Just see it kind of can get started there. If you go to body here, and you go to, I believe, binary under body, and you click select file, it'll give you a little file picker. And you can sort of pick your file, and that'll sort of allow you to upload that file, the contents of that file, like the raw data inside of it, as your literal body in the request. Okay.
Could you go over that again real quick?
Yeah. So I would like you to make a request to /image-upload, image-upload, a post request. And in the body of your post request, I'd like you to include a file. The file is either a PNG or a JPEG image. It can be whatever you want. Also, I should say I don't have access to these images; they're just being discarded on the server. So like, they're not being stored anywhere or anything like that. So I'd like you to make that request with Postman to that endpoint. In order to upload a file as the body of your request, what you want to do is you want to sort of select body up here, and then on the set of radio buttons here, select raw, or sorry, binary. So select binary, and then you can click select file, and then it'll allow you to pick a file to upload. And once you sort of enter all the right stuff and you click send, it'll send that file and you get back a response. And hopefully it'll be a 200 response. And if it's not, then you know there's a problem. So does that make sense?
Can we see an example of this, please?
Example of uploading the file?
No, I got that part, but I guess I need the bridge between reading it and doing it.
Yeah, I mean, I'll say if this is the one where it would make more sense to do it together, we can do that. Or maybe I can do it and you can sort of follow along with me.
Give this a try. I'll see what happens. So if I put an image in there, got a JPEG, and I have like a little triangle, the file isn't in your working directory. Okay, so
this, okay,
working directory.
do that.
So why wouldn't it be in? So is that supposed to happen?
Is what's supposed to happen?
What
I
she's
guess-
saying is, you see on your binary right next to screenshots, there's a
Mhm.
yellow triangle. That's like a
Yeah,
file isn't working.
That's totally fine.
Yeah.
That's
It
totally
worked
fine.
for me, so, and that was my concern as well, but it did work for me once I pressed send.
Okay.
Yep.
And it says image successfully received with a
Yep.
200 okay.
That's good.
Okay. Thanks, Exona. Yep.
No problem. I knew exactly what you were talking about, so.
Yeah, thank you so much. I'm like, that doesn't look right.
I saw someone had their hand raised before, but I didn't catch who it was. Whoever it was, did you have a question?
I did, I guess, it was kind of what Jennifer was asking a little bit, and then because I had the little triangle also, and then also, so once we upload this image, then would I go to the website and be able to see it? So I guess like I feel like I'm doing stuff, but I'm not seeing where it's gonna be, it's displayed. So I'm thinking I sent an image, I should be able to go to the website and find a bunch of uploaded images.
Yeah. If I had made this exercise better, I would have done something like that. That's that's a good point. Right now you're just uploading that image and it's sort of just getting sent to the server, and the server is just like, yep, I got it. And that's all it is. But how this would be used in real life is, yeah, you would do something like you'd upload that image, you'd store it somewhere on the server. And then now you could then, if you store it in a place that the server sort of has access to, you can then make a request to sort of get that image back. And this is sort of how like an image upload thing on a web form might work.
Okay.
Does that make sense?
Yep, thank you.
Cool. Yep.
So, I have this correct, and I guess that's it.
Hey, Ryan,
Yeah.
after class, could you stay a little so I can ask you for some help on something?
Sure.
Thank you.
So what did you mean by making sure that our type of file, like mine's JPEG, matched our MIME? I'm not
Yeah. So when you upload your file, the request is going to contain the contents of that file in its body.
Mhm.
You need to tell the server how to interpret that data. If you were to say, give it a content type of like text plain, it's going to think that data in the body is like text, and it's going to start to parse it as if it's text, and it's going to get very confused because it's not really text.
Oh.
But, oh yeah, go ahead.
Is the path what you mean by MIME? Like it's an image upload, therefore I have to have an image that those match?
I'm talking about like the content type you'd include as a header in the request. So you remember at the very beginning, we talked about content type and accept.
Yeah, so just didn't see that on your screen.
Oh, I haven't actually done the exercise here. I probably should go back over to here to make it less confusing.
Like I have it correct, but I didn't understand what you meant by making sure that the header was the same.
If you're uploading a JPEG, then you want to make sure your content type header is set to image/JPEG. You don't want your content type to be like image/PNG or text/plain, or frankly, you probably don't want to omit it either because you want to sort of tell the server what kind of data you're uploading. And if you uploaded a PNG, then you want your content type header to be image/PNG and not image, or not like text/plain or application./PDF. Like generally when you're sending data that's not text to a server, you want to tell it what kind of data that is. So it has a hint, so it knows what to do with that data.
So at the end of the path, I'm supposed to put in accept : and then the type
Not in the path as a header.
that I want to get back. Okay,
And
so
not accept, you want to do content type. So accept is a header that will tell you the type of data you're expecting to return in a response. Content type is the type of data that you're expecting to send in the response. So you're uploading an image. So you want to include as a header, content type, and then the MIME type of the image you're uploading.
okay, so I think I really need examples here because I'm reading it and I'm trying to do it, but I'm not making that connection.
Okay,
Can you show us?
let's go through it together here. So I'm going to make a new tab here. Okay. So there's an endpoint on the careers in code.ml server, a post image upload. So I'm going to go careers in code.ml/image upload. Okay. Oh, HTTP, forgot that. It's a post. So I'm going to update my method to be post. Okay.
Yeah.
And now I'm going to go over to my body. I want to upload an image. And I mentioned the way you upload an image is go over to body and you go to binary, select your file, do this whole little dance here. I just have a ton of screenshots on my desktop, so I'm going to pick the most recent one I took here. Okay, once I do that, then I need to specify a content type. So now that you've selected the file, set a content type header to match the file format. So my file is a PNG file. So I'm going to go over to header. So I'm going to set a header. And because I'm uploading that image, I want to set a content type, sort of telling the server what type of data I'm uploading in the body of the request. So I'm going to go content type, and my value is going to be image / and it's going to autocomplete because this is a popular one, image PNG.
Oh, okay. I didn't know that's where we had to put it. I thought we had to put the headers in that whole URL.
Nope, headers just go in this section here in Postman. And if
Okay.
I click send, it'll take a second. So you'll notice it's like it takes a bit more time to upload. So the request size here is actually kind of large. It's almost a megabyte, 900 kilobytes. And the response is kind of small, but it's like, it took more time. Like it took a second to upload, and it's because there's a lot of data I have to send here. See, transfer, start, that's a long amount of time. So the larger your image is, the larger the request is going to take. In fact, if your image is large enough, it might crash my server. So please don't make your image massive. Like a multi-gigabyte image would not be appreciated by me or your classmates.
Okay. So not
but-
having headers and it still
Mhm.
worked. How did it still work?
shouldn't still work. My example might be a little bit too lenient.
An image successfully received, and I have a status 200.
Let me see your screen. I wonder if it's possible Postman might be like automatically including a header or something. Oh, it is. Freaking.
I mean, Postman's making it a little easier for us. I like
Yeah.
that.
So let me share my screen again. Let me show you what I just looked at here. So I was here. I clicked on this little hidden thing up here, and I scrolled up, and it was like content type, and it was, if I uncheck it here, it automatically puts it in there. If you upload it, it auto detects the content type of the file, and it's like, oh, I'm going to specify that automatically for you as a header, which is normally really great. But when you're trying to do an example with a bunch of people who are trying to learn how content type works, it makes it so it is a little less good. That's unfortunate. Why haven't I not running that? Yeah.
I have a question. And I don't know, you may be getting to it later. How would this work with fetch? Like how would the
Yeah.
body handle that file?
Yeah. Let's do this. After the break, if folks want, because we're going to have some time with CORS isn't going to take too long, let's build a little image uploader thing in the web browser. That'd be really fun. That uses this endpoint where you sort of select an image and sort of it'll do what it needs to do with the image instead of send it up in the request. Yeah, I think that'd be very educational. We'll do that. And that'll answer your question, but it's not an answer I can just give you sort of verbally right now. We gotta sort of walk through it and try it out.
Okay, sounds good. Thanks.
Yep. Cool. Speaking of though, those are the two headers exercises I have. It's a bit hard to write exercises for these headers because like some of them are just sort of like, oh, it's good to know this. And it's not really a thing you can like explicitly use. It's like a thing you're just going to notice. So I don't have like a lot of great example to try them out, which is unfortunate because that's sort of how you're going to be able to build your knowledge on them. So these were the like, two that I could come up with, which were like, these are some things I can test. But other than that, it's going to be one of those things where we're going to get better at it with time, I think. So let's take our break. When we get back, we'll try out that image upload form thing. And then we'll also talk about CORS. And CORS shouldn't take too long, but this is generally one of those days where there's just going to be a lot of information thrown at you, and it's just, that's how it's going to be. So CORS is another one of those things. So let's maybe be back at like 7:30, and then we'll get into making our image upload thing and do CORS. So see you folks then.